Enterprise education, which plants the sustainable development goals into the Birmingham engineer mind. The Integrated Design Project Suite. I'm Neil Cook, Senior Lecturer in the School of Engineering at the University of Birmingham. I've worked as an engineer in industry, got a PhD in the area of machine learning signal processing, and now run and developed the school's engineering integrated design projects. These are modules which are taught to all of the 1,500 plus undergraduate students in the school and involve 20 plus staff at each year level teaching and supervising groups of students. I'll start this presentation by outlining the integrated design projects, giving an overview of the modules, followed by some considerations on creating the right conditions to teach sustainability development goals, and then finally how we did this embedding of the SDGs on our IDP. For you to gain a feel of what students are doing on IDP, some slides in the presentation will have short excerpts of show reels from the project demonstrations that the students have created, such as the one here. And I'll finish with some general recommendations based on our experience. The Integrated Design Project Suite is a set of enterprise modules which have run since 2017. Each module is taken by 300 to 400 students from several disciplines who complete authentic industrial design challenges in small groups of 5 to 7 people in competition with each other. The challenges are developed in partnership with industry, and recent challenges include designing indoor vertical farms, recycling facilities, and large movable structures such as observation wheels, stadium roofs, and bridges. SDGs play a central role and are embedded in multiple ways across several learning units in the IDP. And this increases the likelihood that sustainability and the agency to affect real-world change become part of the student's emerging professional identity as an engineer. In 2019, the IDP was presented in the IET and Engineering Professors Council publication, New Approaches to Engineering Higher Education in Practice, for its work in incorporating an important skill, creativity, into the programs. And sustainability challenge forms a big part of that creative skill development. Sustainable development goals probably need little introduction to most people by now, but a very quick recap. There are an agreed set of 17 goals agreed at the United Nations in 2015 by all countries, and they are an evolution from the earlier Millennium Goals. The SDGs are designed to make human activity more sustainable for the planet and to improve our quality of life. And importantly, the 17 goals are easily understood and they have underlying progress indicators, 231, 169 targets, and 7 means of implementation. It's the consideration of these progress indicators, targets, and means of implementation that are needed to embed SDGs, and I'll return to these later. The University of Birmingham's IDP can be considered to progress students along two main axes, the problem domain and the discipline domain. As students progress through each year from year 1 to year 3, the problems that are posed to students in their groups become more ill-posed and general. For example, in our first year, IDP 1, students are tasked with a well-posed general engineering problem. This, for example, it could be a miniature prototype bridge that accepts a specified load. Second years, on the other hand, are given an ill-posed engineering problem with different discipline-specific elements. For example, designing a future facility for recycling. Third year students are given an ill-posed general problem which may have multiple engineering subproblems and solutions. For example, improving the logistics in a future smart city. Likewise, as students move through these years of IDP, their professional skills are developed from general engineering team skills in the first year, discipline-specific elements in the second year, which are individual, and finally, by the third year, there are teams of students from one discipline collaborating with teams of students from other disciplines in order to create a solution. In embedding the SDGs, several considerations can be made. We consider involving industry to ensure authentic, future-oriented challenges, and we also consult the engineering education literature for best practice advice. A further consideration for embedding the SDGs is to ensure that the challenges are authentic. And in order to do this, we bring in representatives from industry. We invite them to comment and moderate the challenges and assessments that we develop for students. We invite the relevant industries onto the module to highlight industrial links via supplementary guest lectures and consultation sessions with the students. We also have an optional exercise for students at the end of the modules which get them to reflect on their IDP experiences as part of an application to get a secondment or graduate positions at partnering companies. And this has been successful in securing high value graduate positions for a lucky few. Here are some examples of the authentic challenges we have set students in recent years with the industrial partners. Future air transportation, where students develop concepts for small electric motor planes in future in conjunction with BAE Systems. Indoor vertical farms, where teams of students each focused on one part of the world and design a facility to feed a local urban population, and we developed this challenge in conjunction with Arup. And more recently, recycling facilities, where teams of students looked at the circular economy and designed recycling facilities for manufacturing bases, and we developed this in partnership with Rolls-Royce. And you will have seen in these videos through the presentation so far that all these challenges have common elements which make embedding SDGs easier. They're focused on the future, which allows students to consider materials and technologies and smaller carbon footprints, and they're targeted at future populations whose needs must be considered, and they're all designed to get students to think about creating greener solutions, the quest for sustainability. We also consult the education literature for best practice, and from that we identified 4 ways to embed sustainability in modules, to expose students to issues in existing modules, provide specific modules for sustainability, or have a distinct degree track which focuses on sustainability, or to intertwine sustainability as a concept into the modules. And this is the approach that we use. Furthermore, there's some caveats in doing this, in group modules where typically sustainability is best embedded for large challenges. You've got to account for underdeveloped group work skills, and there's also difficulties for students in relating to other disciplines when their own disciplines are still forming, because lots of the sustainable development goal motivation is around different disciplines working together. I'll discuss now how we embedded the SDGs into the IDP. First thing we do is develop the sustainability literacy of the students. We then align the values the students place on the SDGs to their literacy. We look at the indirect and direct relevance of SDGs to the work the students are doing using causal mapping. And finally, we look at sustainability engineering tools such as life cycle analysis. The teaching on IDP is a mixture of professional and technical skills. We have what we call design impact sessions where we focus on the skills: project management, health and safety, enterprise, and creativity. And we have a series of sessions on sustainability where we first develop students' sustainability literacy, introduce the SDGs once the sustainability literacy has been established, and how these SDGs can be implemented, their means of implementation. And once we've developed this foundation, we then introduce tools for engineering in order to create sustainable designs. So for this first step in SDGs, we develop a student's sustainability knowledge and literacy, and we use an online test called the Sully test, Sustainability Literacy Test, to induct students into sustainability concepts at the start of the project. The Sully test is a 30-question multiple choices quiz with the option for further questions you can add. And the questions themselves are educational, as they have a lead-in with some component which teaches students about sustainability concepts. So you can see in the example here of one of the questions where you'll have some initial preamble to the question which teaches the students about, for example, keeping temperatures in moderate ranges, and then asks the students a question about that concept. We get students to take this quiz in their group of 5 to 6 persons and then report their individual and group average against other groups. So there is some competition for a group to develop their sustainability literacy. Each question in the Sully test is mapped to multiple sustainable development goals, and the results can be combined to give a view of the student's literacy against each SDG. Here is the result of the average score for the 2020 cohort. Each SDG, which you can see here, has a percentage of correct answers, which you can see in blue, students who are not sure, and then wrong answers. The more correct answers in blue, the more literate the cohort is about that particular SDG. And in this particular cohort, it can be seen that SDG 15, life on land, is at the top, whereas SDG 07, affordable and clean energy, is at the bottom for sustainability literacy. And we can use this data across years to note trends and change in cohorts, as well as differences between groups. We also get students to score SDGs and how they relate to their challenges that are set. The idea behind this is that the most important SDGs should correspond to those that the students are most literate about. But this is not always the case, and identified disparities can be used to make teaching innovations. For example, being engineering students, SDG 09, Industry, Innovation and Infrastructure, figure highly as applicable to the challenges that we set them. And students are encouraged to improve their understanding of this SDG by recognizing that their literacy in the Sully test that you saw on the previous slide is actually quite low. While there are direct relationships between SDGs and students' challenges, there's also indirect relationships. For example, a waste recycling plant, which is the challenge we set this year, would reduce local unemployment and help progress SDG 8, which is the decent work and economic growth. So we get students to identify these indirect progressions of SDGs by using what's called a causal map to help to identify all the SDGs and whether they are positively or negatively affected by their challenge. And this gets students to think much more broadly about SDGs and how they can all be applied to their project. Finally, with sustainability literacy, values, and agency developed, we task students with sustainability engineering exercises regarding life cycle analysis using off-the-shelf engineering tools such as CES EduPack, whose screenshots you can see here, where students can look at material selection and life cycle analyses and carbon footprints and energy use. And we find that these are much better motivated using these tools for life cycle analysis with the grounding we've given students in sustainable development goals that have been described in this presentation. We further embed SDGs by incorporating it into our summative assessment, where we assess the project's impact on the wider world. And as part of the descriptor of the assessment criteria, you can see in bold print here we have the impact of the project solution on the wider world is clear from how students propose to progress as many SDGs as possible with reference to their progress indicators and means of implementation. And also their groups have to demonstrate high sustainability literacy. To summarise, here are my recommendations for embedding the Sustainable Development Goals. As a foundation, we've developed students' SDG knowledge from first improving their sustainability literacy, then looking at the SDGs that the students value versus the relevance to the projects we ask them to undertake. Once this foundation is established, we can then activate their aligned values and knowledge in order to progress the SDGs as part of their engineering learning and practice. And this includes causal mapping of the SDGs to the project and motivating the use of sustainability engineering tools. If you want to find out more about the IDP suite, there's an official promotion video on YouTube, which I've linked here, and some articles I've also written about the modules. You can also contact me if you would like to know more.